interference of light waves and Young's double slit experiment. Now let us discuss about interference produced by light waves. This experiment was first carried out by British physicist called Thomas Young in the year 1801. In Young's experiment, a monochromatic light from an illuminated slit S is allowed to fall on two symmetrically placed parallel slits S1 and S2 that are very close to each other and are at equal distance from the source S. The two slits start producing cylindrical wavefronts. Since the wavefronts produced by slits S1 and S2 are generated from a single original wavefront, the waves from slit S1 and S2 will have same wavelength, frequency, and equal phase difference. Hence, they can be called as coherent sources. The wavefronts emerging from S1 and S2 will interfere in space and produce a pattern on the screen. The pattern will consist of bright and dark bands parallel to the slits. Such type of patterns are called interference pattern and bands are called the interference fringes. Now, if two waves of light arriving simultaneously at a point in space are in phase, constructive interference takes place. The intensity will be maximum at that point, hence we get a bright fringe. Similarly, if two waves of light arriving simultaneously at a point are in opposite phase or out of phase, destructive interference will take place. The intensity will be minimum or zero at that point, hence we get a dark fringe. In this way, alternate bright and dark fringes are formed on the screen. Now, in this experiment, if we close one of the slits, the interference pattern disappears and we see only a plain light on the screen. This shows that two coherent sources are required to produce interference pattern. Now, let us find the distance between two consecutive bright or two consecutive dark fringes. It is also called as fringe width. Here, let the distance between the two slits S1 and S2 be small d and the distance of the slits from the screen be capital D. The central bright fringe is formed at the point O. Since the point O is at equal distances from S1 and S2, the path difference at this point S2O minus S1O is equal to 0.
Sigi point you koina P na hai. Sigi mafam je koi dark region tagadra bright tagadra koi khangdri buko. Adari sigi distance koina O degina e lapi na khalase. Adari mo sigi slit siga screen siga. Sina koi screen du lejare. Sina slit lejare. Slit siga screen siga capital D lamne na khalase sina. Slit ani ki arapa sina koina small d lapi na khalase. Adi slit ani se kedoba sagi center of the kedoba screen degi lap mana ini ko. Sagi sigi center of screen si perpendicular si sigi point si degi S1 AP dana ko si da wave si mana ko lo la khadin si mana ko adagi S2 degi P da mu la khadin wave point mas mana wave point la khadin adi mobile is point P je thingjen na doi ne thingjen na bo matam da kedoba crest ka trough ka thingjen na ma ga di constructive interference thomaga bright region phangdoi ne kari gumba crest ka trough ka thingjen na ma ga na destructive interference thogadoi ne adudi destructive interference thoke hai ta de ke dai constructive interference thoke hai ta de ke dai adu ne ba khoi ne maru ne saka toi si ko phare yamu let's koina kana sangi sida S1 amadi S2 ji kanano moje two slits ko two slits or two source koina interference thong na bagi dong ta source ani dakar tai adu source ani do kana oinba S1 ki S2 oinba koina slit oina treat to ji kari gino monochromatic light wave ꯑꯗꯨꯗꯒꯤ ꯀꯩꯗꯧꯕ coherent light wave monochromatic light wave ꯁꯥꯒꯠꯅꯕ ꯍꯣꯠꯅꯕ ꯃꯇꯝꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ source ꯗꯒꯤ ꯂꯧꯔ ꯇꯥꯔꯒꯗꯤ ꯑꯩꯈꯣꯏꯅ monochromatic light wave ꯑꯃꯗꯤ ꯀꯩꯗꯧꯕ ꯑꯩꯈꯣꯏꯒꯤ coherent light wave ꯁꯤ ꯐꯪꯕ ꯉꯝꯗꯦꯕ ꯑꯗꯨꯅ coherent ꯐꯪꯅꯕꯒꯤꯗꯃꯛꯇꯅꯦꯕ ꯑꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ sustained interference ꯀꯥꯏꯅ ꯀꯧꯋꯦꯕ ꯁꯤꯗ ꯂꯥꯛꯀꯗꯣꯏꯁꯦꯀꯣ ꯐꯔꯦ sustained interference ꯇꯨꯅ ꯀꯣꯟꯅ ꯑꯃꯨꯛ ꯂꯥꯛꯁꯤ ꯁꯤꯗ monochromatic light source ꯐꯪꯅꯕꯒꯤꯗꯃꯛꯇ ꯑꯩꯈꯣꯏꯅ slit 1 ꯑꯃꯗꯤ slit 2 ꯁꯤ ꯊꯝꯃꯤꯕꯅꯦꯕ ꯑꯗꯨꯗꯤ slit 1 ꯑꯃꯗꯤ slit 2 ꯁꯤ ꯀꯅꯥꯅꯣ ꯀꯣ ꯃꯣꯏꯁꯦ wave front ꯒꯤ source ꯅꯦ ꯍꯥꯏꯔꯁꯨ ꯌꯥꯏ light source ꯅꯦ ꯍꯥꯏꯔꯁꯨ ꯌꯥꯔꯦ ꯃꯊꯪꯗ D ꯁꯤꯅ ꯀꯅꯥꯅꯣ distance between the slit and the screen adudagi A sina kanano distance of any point P any point P from center of the screen dagi any point P gi arapa ji koina distance A na loksale adudi yengsi akoina hoji puthoktu ji kanano sidaina sibok ke ani gi arapa dune sigi arapa ji dagi sigi arapa ji khaidongna taragadi mobani gi path difference ama phambra हाइदि S02 दगी लाकपा वेब सिगा S1 दगी लाकपा वेब सिगा अनि की पाथ डिफरेंस तो फंगगदि अखोइना मोइदुदा कंस्ट्रक्टिव इंटरफेरेंस थोई डिस्ट्रक्टिव इंटरफेरेंस थोई खंगदोइ नत्रो अदन अखोइ बानि अखोइना हुजिक केदो बचंगे पाथ डिफरेंस हान होट बचंगे नाउ द पाथ डिफरेंस इज पाथ डिफरेंस तो कोइना डेल्टा x न डिनोट होइदना कनाना पिरने दुदि S2P minus S1P na bibra yare ko adadi akhoi si path difference leijagre se koni question number 1 na thonjamra siko sali thorke delta x equal to S2P minus S1P let's call it the question number 1 adadi yengse koina angka je huji puthongna bidamta magi distance ke kaje koi kaim khangdeba koina huji laiba d amadi ke doba si A small d guy small d walam hai ko small d jina kanano distance between the two slit ani ga rapa ji ko ni small d na dino tore adudi small d ji lap manana haidi S1 ji dagi perpendicular distance ma kon samani yelakse perpendicular ma kadai da screen ji da S2 dai ju perpendicular ma na koina capital A harage si point na capital B na maming thonjala siamo nasagi O dagi na sigi center dagi na S1 boke arapa ji mane habani na O dagi na A boke arapa ri kya ta re D by 2 tabra D by 2 samana na O dagi na B boke arapa ju D by 2 tare da na ko pare adu de mo koin hojik right triangle ni phangbre mo S1 P A habama S2 P A habama S2 P B habama sigi right triangle ni jidi in triangles S1PA and S2PB ade hypotenuse square is side ani gi square gi sum ga mane na haigibni na S1P whole square equal to S1A whole square plus AP whole square. So question number 1 and tholase and S2P whole square equal to S2B whole square plus kana BP whole square sini question number sina 2 hage do sina 3 hage do ko 1 di leje gre dana and equation number 3 dagi 2 mu khai dokse equation 3 minus 2 question 3 dagi 2 khai dokse dadi left side machine khai dongna si S2P whole square minus S1P whole square equal to sigdi S2B whole square plus BP whole square minus S1A whole square whole square plus AP whole square sini ba pwede leisi jadi sida S2B ji kanano S2B mali D ga manadra aduna mai mo ta koina B square ang har ko ya plus BP ji ko BP si dia koina akhang ba kedo ba sidagi OP ga OB ga tingsinaba manadro aduna mai mahuta OP plus OB whole square yako BP gi mahuta OP plus OB harakpa adugo masagi square am lejiram bagi square thambire adagi minus se bracket hangaki ngo minus haraki S1A square S1A di kanano S1A di D ga jamana idana aduna se D square minus lai sina minus lai jadi AP is di kanano AP is di OP dagi OA khaidok natro aduna OP minus OA whole square yari bo sibo adadi sigi tamani jamana re sigi D square sidasuna minus D square ani ji kakthana garga ko ji kanada nemore sida kanada nemore gemo OP plus OB OP ji di kada OP ji di A natro aduna A sinjalauro OB ji di kanano OB ji di D by 2 D by 2 whole square minus lao OP gi mahuta A sinjalo minus OA gi mahuta kanana ani OA gi mahuta D by 2 la ani sisu chamana D by 2 whole square ko okay kono ji left side le horsina S2 P whole square minus S1P whole square S1P whole into S2P plus S1P na thamba so from the right side sina kana lakpa A square minus B square pala jare nata bi si odum sadoga pala jare sadok ta le ko si kya tarani mo A square plus harga twice AB twice A la A into D by 2 adi 2 ga cancel kaga A D mathana ta hobra plus harga D square by 4 yare ko minus harga kana la minus harga sidong panselo A square sidana twice AB do mota minus lakado entra minus twice AB lakado ni adidi kanadan ta hore A D kadan ta hora wa A D kadan ta hore samana na plus harga D square by 4 ade bracket hango sona kande mo adidi A square minus AD plus D square by 4 minus na into toropa je manung le ibu sign ni lo change to hai bane minus A square plus AD minus D square by 4 plus ni ko sigi plus ni adi D square by 4 ga minus D square 4 ga kak ya ko le mo se twice A D mathan le mo adu ye ko gi right side ta di kana na si right side ta ko na pa mi di na sa ge S2 minus S2P minus S1P sine adi si thamo ro da si gi tham sina laida right side ta divide out rani S2P minus S1P thamo ro kanda consider divided by S2P plus S1P dai see S2P minus S1P di question number 1 di kana na se ko gi delta x ta re na part difference ta re sida di kana ta re twice AD yung S2P ga plus S1P S2P ga S2P ga S1P ga si yeng se na hai screen jina yamna lap khyo matam da hai screen jiga slit ji yamna lamna ba matam da ani ja phet mana kani ba adu do mana yena khal kan ji da kun bi da re D plus D na la ne ko si di yung since ko or when the screen is very far ko and far wa ji matam da ke da re ba S2P is nearly equal to S1P is nearly equal to D si concept se ko ni assumption option bane re makara kai tare se twice D dar pra twice D tu ga si into to ready si ga divide to ready kya tare 2 ga ka khraga A into D divided by kana tare D na le ho pura sa ꯑꯩꯈꯣꯏꯒꯤ ꯗꯦꯜꯇꯥ ꯑꯦꯛꯁ ꯀꯣ ꯑꯗꯨꯗꯤ ꯑꯦꯅꯤ ꯄꯣꯖꯤꯁꯟ ꯉꯁꯥꯏꯒꯤ ꯑꯩꯈꯣꯏꯒꯤ ꯄꯣꯖꯤꯁꯟ ꯀꯅꯥꯅꯣ ꯍꯥꯏꯕꯁꯤ ꯄꯨꯊꯣꯛꯈ꯭ꯔꯗꯤ ꯀꯌꯥ ꯇꯥꯔꯦꯁꯦ equal to sina sida course karo adidi delta x into d by small d dara sumai to no koi any position je do wa sina pirane sigi question pirane delta x na kari path difference capital D is na distance between slit and the screen small d is na kana koi gi slit ki kado distance between the two slits adudi yenga je ko na ngasai asigi mafam sida constructive interference tage di ketok tai destructive interference tage hai ta di ketok tai kada sigi question sida sigi mathaki question sida yengsi ko sina sida this is the question for distance of any point P from the center of screen. Center of screen dagi lapeva distance of course mai to na puthokani adidi constructive interference dadi path difference to kya ta hai koida mamangi classing da kun hai gi do kamain hai gi ba constructive interference to ke hai taragadi magi path difference to for constructive interference ta delta x kana gamana ba delta x ya kuna n lambda hybra delta x upon n lambda where n equal to 0 1 2 3 4 hai gi to adu di mo koina delta x ki value diga dai si da gi mo a d by d hydro adu di a d by capital D equal to n lambda hybra plus there upon a puthok se di kai tare n lambda capital D by small d for nth nth suba khoi gi ke doba nth suba distance nth suba bright fringe hai tare constructive interference tadi bright fringe ni na akoni center of ke doba screen dagi nth suba bright fringe kadai de phanga dagi matam da kadai phanga ne ba n lambda d by d de phanga ne adu n dagi -1 am hat tar di -1 n -1 na la ka de ko the 5 suba hai ke ta di a5 distance of the 5 bright region lo 5th bright region ko manga suba bright region kadai de ta ga de matam da si da 5 hapsalani n gi value 5 hapsalani lambda gi value sijinarani akone light source to gi wavelength sijinarani distance between the slit and the screen sijinarani adagi distance between the two slits sijinarani aduga sigi question de pala kun hot kane yani ko adade mo ngasai koina kai haigre koina mamangda young double slit experiment phangai ba bright fringe amadi dark fringe ki which is amane habane la pa is amane habane sigi dark fringe ga bright fringe ani je la pa is sab amane habane adadi bright fringe ani gi kedoba distance ki khadong na do phang ta ragadi koida dark region se phangra sa dark fringe ki region dark fringe ki distance se phangra chumai to na koina pot kani ko then fringe width okay now again fringe width koina beta na mo chili ko fringe width beta hai ji kana na pi de ba ngasai gi sigi yong sigi na koina n ne hai ji adadi sidi n-1 ta dro magi position je sina n hai ta gi sina n-1 hai di sina 5 ne hai ta gi sina 4 ni na adadi 5 ka 4 basically 4 si ama handa ni na sina n hai di sina n-1 sina n plus 1 hai gi sina n oi sini adu mai to na koina che do ba a n minus a n minus 1. Hadi distance of the nth region minus distance of n minus 1 region. Hadi distance of nth region this is equation n lambda d by d minus n have 5 4 3 2 kind of my season as 5 ka 4 go is go thangnabani gi खाइदोंनबदु बखोइना कना फंगेबा फ्रिंज विथ न फंग कदोइने and minus हाइगा सिदा n gi मुत कना लानी सिदा n होबदम n हाइगिने सिदा 5 हाइदि सिदा 5 लाखदे नत्रा सिदा 6 हाइदि सिदा 6 सिदा 100 हाइदि सिदा 100 अरे सिदा n minus 1 हाइदि सिदा n minus 1 से n minus 1 हाइगा lambda d by d सिदा n lambda d by d हाइगा सिदा minus n lambda d by d tare plus lava minus minus plus lambda d by d tare अरे सिदा कोई कना लाइरे सिगा cancel set करे lambda capital D by small d and कोई की fringe width से कना depend करोगे मो this is the equation for fringe width and fringe width is directly proportional to wavelength greater the wavelength greater will be the fringe width and distance between the slit and the screen greater the distance between slit and the screen greater will be the fringe width and lastly distance between the two slits is smaller than the fringe width will be greater and directly inversely proportional to the distance between the two slits and directly proportional to the wavelength distance between slit and screen necessary condition or depending factors in
Conditions for sustained interference. The following conditions are necessary to obtain a continuous or permanent interference. The light should be monochromatic. If this is not so, the fringes of different colors will overlap. The two sources producing interference must be coherent. The wave trains causing the interference must have light waves of the same wavelength and same velocity. The two interfering wave trains must have the same plane of polarization. To observe interference fringes clearly, it is necessary that the fringe width is sufficiently large.